November 30th, 1942, somewhere in the South Pacific, the USS Pensacola is burning. A Japanese torpedo just hit her below the waterline, tore through the stern, below her steering gear, and nearly split her in half. There is no dry dock for 2,000 miles, no harbor big enough to cradle her broken hull, and yet she's not going to sink. Not if a handful of machinists and welders have anything to say about it. This story is about machines, but not the ones you see in museums. These were held together with spit, sweat, and stolen steel. This is about how improvised engineering, welding, machining, and sheer human grit kept the Allied war efforts alive even when the textbooks ran out of answers. On the edge of a battlefield floats a ship you've probably never heard of, the USS Vestal, an unassuming repair vessel packed with 600 craftsmen, blacksmiths, pipe fitters, electricians, and machinists. Jake wasn't a fighter, he wasn't a sailor, he was a problem solver, and right now he's staring down Pensacola's twisted hull and asking himself, how do we fix a ship this broken with what we have on board? Step 1. Remove the damage. Jake's team cut away nearly 4 tons of needle steel by hand. No robotics, no lasers, just torches and 12-hour shifts in 100-degree heat. Step 2. Reinforce the spine. They scavenged I-beams 12 inches thick from a ruined dry dock and weld them together into a cage that braces the hull from the outside. It's not elegant, it's not even safe, but it works. Step 3. The shaft. The torpedo bends head drive shaft, just a few thousands off, but that's all it takes to kill a ship. So the crew rigs a portable boring bar inside the hull, essentially building a lathe inside the engine room, and machines the shaft back to true, by feel, by eye, and by instinct. 20 days later, Pensacola limps into Pearl Harbor, held together by beams, bolts, and belief. Half a world away, the Soviet Union is facing a different kind of disaster. In 1941, Hitler's armies tore through Ukraine and Belarus, capturing or bombing out entire industrial zones. Stalin's response: move the factories. Not some, not a few, 1,500 factories, 1,500 factories torn down, loaded onto trains, shipped east into the Ural Mountains, sometimes while under enemy fire. One of these engineers was Lumida Kovalenko, 28 years old, leading a crew of machinists into Kharkiv. They had 72 hours to dismantle an entire tank plant. Every lathe, every press, every gearbox. No instructions, no spare parts, just cranes, rail cars, and panic. But here's a part that no one talks about. Some of these mobile factories never stopped working. They machined tank parts on the move, lathes bolted into train floors, powered by diesel generators making crankshaft as they rattled towards the Ural Mountains. Then came winter, minus 40 degrees. Coolant froze into the pipes. They are fixed. Mix kerosene into the coolant and sleep beside the furnaces to keep the bearings warm. They lost nearly half their tools, but by 1943 they were outproducing Nazi Germany in tanks. Why? Because they could machine anything, anywhere. And then there's December 7, 1941, Pearl Harbor. The USS Vestal is moored alongside the battleship Arizona when the first bombs fell. Chief Joe Farquhar, 35 years old, is on deck when Arizona explodes. Fire, shrapnel, bodies. Vestal is literally welded into her side. And if they don't move, they're going down as well. So under fire, Farquhar's men grab blowtorches. They cut the mowing lines while under attack and beach the ship in shallow water to keep her afloat. But that's only the beginning. Vestal's hull is shredded, systems down, tools lost. They scavenge parts from wrecks, file gears by hand, patch bomb holes with concrete and steel plate. No manuals, no second chances. And within weeks, Vestal is back in service, repairing other ships that barely made it out alive. This is the real engineering of war, not sterile labs or blueprint-perfect factories, but cracked ships, frozen tools, cannibalized steel. It's machining without backup, welding with your back against the wall, building with whatever you can carry because there's no time and no one else is coming. No, we're not in a battlefield anymore, but we're still racing the clock, still holding tents, still staring down broken parts with no spares, no manuals, and no time. The only difference, no one is shooting at us while we're machining. Our tools are better, our tech is smarter, but the mindset, the grit, it hasn't changed. We're still improvising, we're still adapting, we're still building the impossible with whatever we got on hand. So whether it's a CNC in a clean shop or a welder in a windy blown yard, this work carries the same spirit that kept ships afloat and factories rolling. And this was just a few stories. There are hundreds more, from desert workshops to jungle airstrips, from field repairs to factory miracles. Because history isn't just what's in the textbooks, it's what's in the welds, in the cuts, in every impossible fix, and we're just getting started.